Okay, so let's have a look at chapter 4, binomial expansion. We're going to expand expressions of that form, so 1 plus something to the power of n, where n this time is going to be either a fraction or a negative number. So we are extending the binomial expansion from last year. So last year you expanded a bracket, a plus b to the power of n, and n then was a positive integer, which is obviously a natural number. So then the formula looked like this: a to the power of n plus, then you had n choose 1, a to the power of n minus 1, and 1b, and then you had n choose 2, a to the power of n minus 2, and then you had b squared to lot those b's, and then it carried on: n choose 3, a to the power of n minus 3, b cubed, and then you could have a term in the middle, so we could say it's n choose r, a to the power of n minus r, b to the power of r, and then it ended up with b to the power of n. So the key thing about this expansion was you could have any number at the start. So for example, 3 plus 4x to the power of 10. If you wanted to expand it fully, you could carry on and write down 11 terms. It would end up at the 11th term, which would be 4x all to the power of 10. Now this year, having the fractional powers or negative power will mean that this is going to be an infinite expansion. So the formula, again, it's in the formula booklet. Provided it starts with 1, it can be written like this. So 1 plus n times x, so the power times x, and then n times n minus 1 over n 2 factorial, or 1 times 2, x to the power squared. Then you carried on n times n minus 1, n minus 2 over 3 factorial, or 1 times 2 times 3, x cubed, etc., etc. Now spot the pattern. There's two things times together in the numerator. There is 2 factorials on the bottom, and there is power of 2. If there's 3 things times together, so 3 consecutive numbers following the power, n minus 1 and n minus 2, there's 3 power of 3, and there's 3 factorial. If you look at n choose 2 from last year, or n choose 2, the definition says it's n factorial over n minus 2 factorial, 2 factorial, which then can be written as n minus, because n factorial is the product of all integers up to n, but you could write it as the product of all integers up to n minus 2, followed by 1 after, so it's n minus 1 and 1 after. And then on the bottom you've got n minus 2 factorial, and then 1 times 2. If you could see, those n minus 2 factorials cancel, and you have got the same coefficient as the x squared term in this expansion. So this n choose 2 is equal to that. Okay, so you've got a different way of writing the same result. Okay, so let's have a look at example 1. Actually, before we do that, this, because it's an infinite series, it only works for, it's convergent only for the values of x between -1 and 1. So you're talking only about decimals. We can write it as modulus of x is less than 1. So let's have a look at the first example. Example 1. We have to find the first 4 terms of the following expansion. So it's 1 over 1 plus x. So I see, well, where is that negative power? Well, if you bring it to the top, you get 1 plus x to the power of minus 1. So here is the negative power. So let's just substitute this the value of n minus 1, and x is just x, into our expansion. So we're going to start with 1, then we're going to have minus 1 times x, then we are going to have minus 1 multiplied by minus 1 over 2 factorial, or 1 times 2x squared. Then you're going to have minus 1 times minus 1 times minus 1 minus 2 over 1 times 2 times 3x cubed. And you could carry on like this, but we've been asked to only write the first 3 terms up to the x cubed term. Tidy up the coefficients, minus 1x, so it's minus x. Over here, pop all of this into the calculator. Don't risk making silly mistakes. It is going to be plus x squared, and then again pop all of this into the calculator the way it appears. It's going to be minus x cubed. You could also write it like this, so you could say that it's approximated by 1 minus x plus x squared minus x cubed, so you don't need to do plus dot dot dot. Okay, so we have a look at example 2. Let's just have a look what they're asking us to do. So in the example 2, this time it's 2 parts. So the first question asks you to find the binomial expansion of 1 minus x to the power of a third. Okay, so here n is equal to 1/3, and x is actually going to be minus x. Okay, so in this, rather than having 1 plus x to the power of n, that plus x has been replaced with minus x. So let's just copy down the formula, just so it's always a good idea to quote it in any exam question. So at least that's enough. Let's start expanding. So we've got 1 plus the power is at 1/3 multiplied by minus x, because we've replaced x, positive x, with minus x. Then you've got 1/3 multiplied by 1/3 minus 1 over 1 times 2. Then you've got minus x squared. Then one more, 1/3 minus 1, and 1/3 minus 2 over 3 factorial, so 1 times 2 times 3, and x cubed. Okay, let's tidy up each coefficient really carefully. 1 minus 1/3 of x, plus here you would pop all of this into the calculator and then multiply it by, you always have to take the number in front of x and square it. Obviously, if you know that minus 1 squared is 1, you don't need to put it in this instance, but if it's anything harder, you're better off making sure that it's carefully done. Okay, so let's have a look. This is going to be 1/3 times minus 2/3. It's going to be minus 2/3. It looks like it's going to be 1/9, because you have 1/3 times 2/3 over 2, so it's 1/9 x squared. And this one here, again, if you tidy it up, let's just actually use a calculator. I forgot to put minus x cubed. So let's do it. You're going to put 1/3 multiplied by 1/3 minus 1, and then multiplied by, again, 1/3 minus 2. That's, I wonder whether I can do that. Yeah, okay, it moved the 1/3 in the bottom, but it will be still correct, over 2 factorial, so that's going to 3 factorial, which is 6, and then multiplied by minus 1 to the power of 3. So obviously we know that it's, but close the brackets after minus 1, so it's minus 5/81 x cubed. Okay, for the next part, it also asks you to state the range of values of x for which this expansion is valid. So it's minus x, it must be less than 1. So here we need to divide by, because modulus of minus x can be thought of as modulus of minus 1 times modulus of x, but modulus of minus 1 is 1. So effectively, it's just modulus of x less than 1. Okay, so because the following is true. Okay, for b, we are going to do 1 over 1 plus 4x all squared. So let's bring it to the top, 1 plus 4x to the power of minus 2. We want the first, all the terms up to the x cubed term. So let's write down the first term. So that's 1 plus the power comes down, so it's minus 2. Then you multiply it by 4x. So your x has been replaced by 4x, and this is n. So this is going to be multiplied by 4x. Then we've got minus 2. Then minus 2, take away 1 over 1 times 2, 4x squared. One more, minus 2, minus 2 minus 1, minus 2 minus 2 over 1 times 2 times 3. And then we have 4x all cubed. Tidying up the coefficients, so you have 1, then it be minus 8x. This one here into the calculator, you are going to pop these and multiply them by 4 squared. So that's going to be minus and minus plus, and that's going to be 16 times 3, which is 48x cubed. And this one here, minus, that will give me minus an answer. And here we are going to have 4 times 4, 16 squared, 256. Sorry, that was squared, that is x to the power of 3. And it's valid, well, your x in this expansion, which was valid for modulus of x less than 1, has been replaced with 4x. So 4x must be less than 1. So if you divide by 4, that means modulus of x is less than 1. Modulus of 4x, so anything between not 1 minus 1, it's going not between minus 1 and 1, but minus a quarter. Forgot to divide it by 4. There you go. Between minus a quarter and a quarter. Okay, so for question for not question, example 3, we have, let me just make it bigger so I can see it. Okay, so again, there's more than one part, there's 3 parts. The first question is square root of 1 minus 2x, and we need to go up to x cubed term. So this one, let's write it with power. The power here is a half. X has been replaced by minus 2x, and n is equal to a half. So let's just quote the formula. Again, it's 1 plus the power times x plus n times n minus 1 over 2 factorial x squared, etc. So it's 1 plus the power, which is 1/2, multiplied by minus 2x. You can write 0.5 if you prefer. The next one is going to be a half, then a half minus 1 over 2 factorial, and it's minus 2x squared. Plus you've got a half minus 1, a half minus 2, 1 times 2 times 3, minus 2x cubed. Just tidy up a little bit, so it's 1, then you have minus x, pop all of this into the calculator, but then times it by minus 2, close bracket squared. If you don't close brackets after minus 2, you're going to make a mistake. So that's going to be a half, and then minus a half, and then plus. So it's minus answer 1/8, and the 2 squared over 8. So 4 over 8, so that should be a half, x squared. and this one is going to be positive, negative, negative, and then you've got -8. So again, this one here, you pop all of this into the calculator and you times it by -2 cubed. So let me just show you, just so you've got another example. So let's just use 0.5. So you do 0.5 in the top, multiply it by 0.5 minus 1, multiply it by 0.5 minus 2, and then on the bottom of the fraction it's 1 times 2 times 3, and then multiply it all by -2, close brackets, cubed. Oh, I think I need to put the times symbol there. Oh no, I forgot the brackets here. Maybe it will like it now. Yes, so the answer is -1/2. There you go. So this is equal to approximately to this expansion. So what value of x is it valid for? So it's for -2x being less than 1. If you divide it, remember we showed on before that -2 is going to be 2, so really, you know, -2x is equivalent to modulus of 2x. So it's just 2x is less than 1, divide by 2, modulus of x is less than 1/2. Okay, for part B, we've got to substitute x equals 0.01 to find the decimal approximation to √2. Okay, so in those questions, they are giving us the starting value. We are going to substitute it into the left-hand side. The left-hand side is this, because that is our original starting point. So we are going to substitute 0.01 into this. You could just do it on the calculator. So it's 1 minus 2 times 0.01. That gives me 7 √2/10. Now this is going to be equal to, let's do some work on the right hand side, we'll make it equal to, and on the right hand side is this expansion. So we are going to substitute 0.01 into this expansion. So the best way to do it is to use the ANS key on the calculator, so you are less likely to make any mistakes. So if we put 0.01 equals, and the ANS key can be used instead of x's. So you put x minus 1/2, so 0.5x squared, minus 1/2, so 0.5x, which is ANS cubed. There you go, and the answer we obtain is 0.98999495. Okay, so what we found, that 7 √2/10 will be approximately equal to 0.98999495. Well, how am I going to use this to find the answer to for √2? So approximately equal to, we need to get rid of that 7/10. So times that by 10, divide by 7, or divide the whole thing by, because 7/10 is what it's multiplied by, so divide it by 7/10, which you can do it on the calculator. So I'm just going to times it by 10 and divide it by 7. The answer I have is 1.414213571. Now if you go to the calculator and put in √2, it gives you 1.4142356. So you could see that both of these will round up to 4142136. So they are correct too. So they agree to 1, 2, 3, 4, 5, 6, 7 decimal place only by using short expansion up to the third term. Okay, so for part C, without further calculations, state how the accuracy of this approximation could be improved. Well, you could by evaluating more terms. So for example, the x squared to the power 4 and x to the power 5 terms. So just by using x to the power 4, it's going to be more accurate. Okay, let's move on to example 4. With the example 4, we are asked to now look at the following function. F of x, so this is 4, is equal to 2 plus x over square root of 1 plus 5x. So these are quite common, those questions. So the first thing we're going to do is bring that awkward denominator to the top. So it's going to be 1 plus 5x with the appropriate power, so minus a half. Now we're going to expand this and multiply it by 2 plus x. So in this question, they are asking us to find the x squared term. So I'm going to expand this up to x squared term. So 1 is always 1, then it's n times x. My x is 5x and n is minus a half. So it's going to be minus a half and then 5x. And then we have minus a half, minus 1 over 1 times 2, and then 5x all squared. Tidy up 1, and this is minus 5 over 2x, and this one here is going to be minus and minus, so that becomes plus. That's going to be n8, and then 3 over 3/8 times 25, so it's going to be 100 and no 25, not 5 times, is that 5? No, 3 times 25 is 75 over 8x squared. Perfect. So what we're going to do now, we are going to multiply this by 2 plus x. So the way I like to do it, I'm just going to use that answer and just create a grid. Only need to go up to x squared term. You can actually only find the x squared terms, but I'm just going to do it fully. Okay, 75/8 times 2 is going to be 75 over 4 x squared, and then 1 times x is x minus 5 over 2 x squared plus 75 over 8 x cubed. I definitely don't need this one, so these could be gathered. I'm just doing it for practice, otherwise I would only look at these two added together. So my expansion is going to be 2, and then 1 and minus 5 over 2 is minus 3 over 2x, and this here is going to be 75 over 4 minus 5 minus 10, so it's going to plus 60 5 over 4. That's, I hesitated around the one that we want, so it's 65 over 4 is the coefficient. We were asked to find the term though, so this is the term. Okay. For part B, we are asked to state the range of values of x for which the expansion is valid. So the only part of the expansion is this one here, the denominator brought to the top, that has restrictions on what values it is valid for. So with modulus of 5x needs to be less than 1, giving us modulus of x is less than 1/5. So anything between minus 1/5 and 1/5. So this takes us to exercise 4a.